Good morning, one and all. This is Harita Kea from Government College of Technology, Coimbatore, Department of Manufacturing Engineering. Today, I am going to give a review on my mini project on the topic called Fabrication and Analysis of 3D Biocompatible Artificial Teeth using PMMA by 3D FDM Printer. Under the guidance of Dr. T. Shegar, Associate Professor and Head, PG Manufacturing Engineering, Department of Mechanical Engineering. These are the objective to study the fabrication of artificial molar in dentistry application and its challenges involved, to identify the feasible solution by the way of using 3D printing technology, and to fabricate the artificial molar using the polymethyl methacrylate, that is called as a PMMA, by the 3D FDM printer. FDM is nothing but the fused deposition modeling as a technique of a 3D printer, and to evaluate the properties to fabricate the 3D printer molar using the various properties need to be evaluated. Likewise, test mechanical, chemical and bioanalysis. Then introduction. So recent advance in the digital technology and their application to the dentistry, mainly in the field of dentistry related field. It is like prosthodontics, orthodontics, oral and maxillofacial surgery, endodontics, and have resulted in the development of techniques that may be used to improve our clinical practices. Few important techniques are the cone beam computer tomography, it is called as a CBCT, 3D printed object by using the various softwares like SolidWorks, Creo, CATIA, etc., and with the uses of the CAD and CAM. And 3D scan gives information in detail about the anatomical structure to be a 3D printed object. There are various techniques of 3D printing, mainly stereolithography. It is nothing but an SLA, selective laser printing, by using the powder kind of raw material which is used to, by using the laser print we can fabricate a 3D component, that is called as a selective laser printing, and fused deposition modeling in dentistry to get a product. Three-dimensional scanning helps in assessment of teeth to produce a hard soft tissue through the creation of 3D objects. And this is about a methodology. The various literature had been taken, and to review about that technique, how they current situation to provide that material to be withstand by using the as a biomaterial in the human body, and problem identification, design and analysis. So 3D CAD, which is used for analyzing and modeling the software which using called as a SolidWorks, and Cura is a software which is used for slicing the G code analysis, where thereby using the FDM printer to print fabricate a component. On fabrication, we use that FDM, that is a fused deposition modeling 3D printer. Experimental test and analysis, we have taken the various of 6 tests, that is tensile test, compression, water behavior test, wear, sim and flexural strength. The flexural strength is nothing but we need to take up the shear and wear strength for the analysis, so that material can able to withstand with that particular property in the human body. And last result and discussion and conclusions. So these are the application we can able to fabricate by using that kind of a PMMA material for wearing using different techniques in the 3D printing. Moreover, in foreign, the conventional aligner and the splint, various tray, artificial teeth with a denture, so they can able to make by using the SLA technique, that is a stereolithography, where the acrylic resin will be taken as a raw material, it like a powder material, they will be infused with a liquid solution, so they fuse it together form a solution. So with that varies of the temperature, the model is created and it is loaded to that SLA printer, and from that it will take a print and it forms a acrylic artificial teeth. By my project has taken that the crown need to be taken, that is same as of artificial teeth, by using the FDM printer. So same that with respect to the different convention of the 3D printer is varying here. So we can able to produce the splint or aligner. It is nothing but we can make the misalignment of the teeth. Moreover, nowadays more of the youngsters were using this kind of an aligner or a splint to take up the best alignment for the teeth to look up their appearance and for the smiling occurrence. And figure 2 shows that the secondary impression tray. This can also be modeled by using the FDM as well as SLA or SLS various techniques. So this is nothing but the color can vary with the material. So the pink color they have using it look like our nature of the tissues and muscles. So this is used to take an impression before we need, if for example if we need to place an artificial teeth at one particular either in an upper jaw or in a lower jaw, so they need to take a impression first, and they will be used to take that secondary impression tray. After that they will be having some gum like structure. It can be jaw fixed to it. It is easily hardened within 2-3-4 minutes, and after that the impression will be taken. After that they will get a impression, and they will be evaluating with using either a wax or a POP to get a proper structure of an artificial teeth. So that can also be taken or modeled by using this technique. And acrylic artificial teeth, this is one kind of a teeth which is a solid in nature. So this can also be drilled by using the various techniques, and the cement which is called as a glass ionomer, which is used to fabricated after the solid component of a teeth is extruded from the FTM or SLA technique. So they will be taking, depend upon each of the person by person, their overall cavity, the upper jaw, lower jaw, the teeth or structure and teeth dimension can able to vary. So we can take, after the impression is taken, then artificial teeth has to be is extruded, and after that it is drilled to the specific dimensions. The use of the glass ionomer cement will be used to fabricate this kind of an artificial teeth into the mouth, and it can be hardened within 5 minutes. So after that the initial glossy finish will be look here for the appearance of the teeth will be look like as same as a natural teeth. So that kind of an artificial teeth can be done. So my project is same as the figure 3 shows the artificial teeth. So they were using the acrylic same. PMA is also an acrylic kind of polymer, but it is either it is PMMA is nothing but the thermoplastic polymer which we are using. And figure 4 shows that acrylic artificial teeth with denture. Denture is nothing but the soft tissue. We call it as a lower jaw and upper jaws. So the first indication with that will be taken to place for the upper jaw, and this can be used to fix it into a lower jaw. So moreover, the upper jaw for the patient who are having the cancer or clot into their oral cavity, they can able to make such kind of an this kind of an denture with the teeth can be able to make for the best look of an impression. So we can use it. So figure 5 shows a provisional fixed partial denture crown. So nothing but this is a crown way of provisional fixed partial. So partial is nothing but we can able to use this crown for at least 3 to 5 years for the better appearance, and we can able to eat as well as but only the disadvantages is that they will be not having any the edges which is as per the natural tooth it will be having. So this is the same technique that the pink color, light pink color, that shows that it is a POP material. After taken the impression from the tray, and they will be having the gum like structures which will be evaluated to take an impression. After that we will be pouring some the POP is nothing but a plaster of Paris. So it will be hardened to such particular temperature. So that pink color shows that. Then that whitish yellowish color shows that it is a provisional denture crown. So moreover, the natural teeth will be drilled to the specific dimension. After that, the crown will be placed by using the glass ionomer cement. So these four teeth were fixed by using that called as a Maryland bridge. So it will be hardened within 5 minutes. So these can be initially will be checking for any plaques or any anti microbial any infection. If it has caused, we need to go to the same dentist for the checking period for at least 1 year or 1.5 years we need to take it, but it can be used up to 5 years. It can able to withstand. So either it may be used in the canine, incisor, molar, premolar, whatever it may be. So we can use it for the artificial denture crown. Moreover, molar and the premolar is inside the oral cavity, so we need to eat something or need to crush something, any food particular particles, so they will be mostly will be going for the metal type of a components. It won't be corroded, it won't be eroded, and it won't get any impact over that to the oral cavity. So in front for the aligned cavity we can use it like this kind of a crown. Then figure 6 shows that the pallister obstructor replacing the lost tissue following the maxillolectomy. So this is nothing but we already seen, we can use it for the various kind of in the dentistry application. This is also one of the kind, that is a maxilloectomy. So they can be called as a maxillofacial surgery. So we need to take up this kind of an palatal obstructor. We can use it for the person having always having the drugs in the mouth, will be placing over for the prolonged hours, days and months and years. They will be having that leads to a cancer or a clot in a oral cavity. So some dentists will take up the better decision to take up to remove that cancer clots, and after that this kind of a material can be extruded by using the various 3D techniques and will be placed inside the oral cavity. It also been seen look like a natural teeth, but it is an artificial one. So this type of a surgery can also be taken place by using the dentistry applications, and this is nothing but a PMMA. I have the various characteristic which is very non-toxic in nature, and it is biocompatible with the oral tissues. It won't cause any damages to the tissues or the muscle nerves for them, and it has rigidity and dimensional stability. We can make up to the dimension with varies with that, and hardness resistant to the scratching. We won't get any breakages or crack during when days follows. When this also insoluble in the body fluids, nothing but blood and saliva, whatever the food we intake. So it won't be soluble at that fluids, and easy of manipulation. We can able to manipulate this easily, and a glossy surface after polishing, color stability, good quality aesthetic outcomes. These are the mechanical properties. It has a density of about 1.18 gram per centimeter cube, and tensile is about 50 to 70 megapascal. Then bending strength is 85 to 110 megapascal. Melting temperature is 200 to 250 degrees Celsius. So it can able to withstand in the human body temperatures. Water absorption is only the 0.3% absorption will takes place over we have prolonged period of year. It has only 0.3%, so it is a better suitable material to be able to fabricate it as crown to place inside the human body. And hardness is about 80 to 100. HRC is nothing but the Rockwell hardness value, and impact is 0.25 joule per centimeter cube, which is very less impact. So we can able to go for that same material of PMMA. This is my experimental model of a crown. So the three figures shows a top view, bottom view and a side view. So I have taken this crown of a same human dental particular application. So it is human tooth. This is a molar kind of, that is a pre-wisdom tooth we will be calling as in a medical term. So this is a model I have been modeled using the software called as a SolidWorks, and the center part of that model will be having a drilled structure like a hole. So it is called as a crown, which is need to be placed by using the original teeth. This is an artificial teeth, so it need to fix it that particular dimension for that. So I've made it the half hollow structures inside the cavity of a molar tooth, and this is have extruded by using the FTM technique. And tooth is extruded, that below layer that is very 1 mm thickness, that is called as a raft, which is used to placing the material in the bed temperatures. And I have displayed that that extruded have using 14 minutes 9 seconds to extrude this kind of a molar teeth within a minutes. Okay, next then experimental model by using the ASTM standard. So this is nothing but the water behavior analysis model extruded by using the FDM printer. So the small circle inside that, it is ASTM standard. So up to the standard which will be given by the ADA techniques, that is called as an American Dental Association. They have given some standards to fabricate the material. Up to that, it need to be withstand the water absorption value by using the various percentage of relative percentage. Will be taking the initial weight of a material, and after that will be a final weight will be when it is immersed in the 37 degrees Celsius of water. At that particular time we can be evaluated with respect to the time, week, hours or days or months. So after that we will be weigh that particular material, how much of the percentage is varying with respect to the weightage of the in grams. So moreover, the large circle is nothing but the same chord which is raft. Have been told in all previous slide. This is a 1 mm layer thickness will be fabricated. After that it will be taken out, and that is a wastage of a material. But we can use that to the small type of material, that is dia 15 mm and thickness is about 1 mm. This is a ASTM standard specimen, and various literature reviews have been taken. So it's nothing but the International Journal of Applied Dental Science, 3D printing in the dentistry. Moreover, they were used the SLA and FTM printer as well as a selective laser printer. So these material with a different variable of a material, and they have analyzed the mechanical, chemical and the bio-analysis of the properties of that material can able to be withstand to that particular properties, so that need to be have been incorporated in the human body. So they have been various analysis of the techniques have been used to test as per the ASTM standard, and this were used by using the characterization of the acrylate based artificial teeth for denture fabrication. It's also a journal of the material science, materials and medicines. The acrylic resins is used in the SLA technique. Then after that it had been fabricated with respect to the artificial tooth and the denture material. After that it had been evaluated with various properties like mechanical, chemical, bioanalysis have been variated, so that it can able to incorporated in the tooth structure, so it won't cause any harm to the material to the human body. They have characterized the various techniques using the thermal analysis. We're using like FTIR and that is nothing but gravimetric analysis, etc. And this is also taken there is a prosthodontic application, the polymethyl methacrylate. So they have been used that PMM material is conventionally available. So with that structure, with that particular of the filament, we cannot be used in a fabrication purpose. So we need to improve the strength. For same as per the composite, they have been using that PMMA material with the for example the nano fibers, fillers, nanotubes, hybrid materials. So they have been incorporated into, they form as a composite, and after that they have been a filament is formed. After that they have been used in the FTM technique to print an object, and how much of the strength is available with and without the composite material. Strength, the mechanical properties are being evaluated, and further work had to be done. It is like a need to take up a part file from the SolidWorks and slicing the G code by using the Cura software as per the standard ASTM specimen which were being given by the ADA association. And likewise with tensile test, compression test, water behavior and wear test has to be taken, and that experiment analysis will be furtherly will be uploaded. And these are the video link which we are using, how that the printer is formed up. So this is a FTM printer, so we having a display with a monitor. So this extruder will be given to incorporated with already with the material that is called as PMMA material, and it will be loaded to get a tooth like a structure. So this will shows that how the material is taken up to the extruder and how the heating nozzle and the bed temperature will need to be maintained it. After that it will be forming to the particular component. And these are the reference have been taken for the literature review and already have been given. And thank you.